Okay, so we are at the end of the today's event, and we have one more topics to cover today as part of the vodQA India 2022 event. And the topic will be like Selenium CDP and BiDi, which are codified browser developer tools. And this talk will be delivered by Puja Jagani. Before I hand it over to Puja, I will quickly introduce her as well as little bit about the topics she is going to deliver. So about this Puja, like she is a Selenium core committer and a member of the technical leadership committee. Puja is currently associated with BrowserStack as team lead. Now coming to the topics he is going to deliver today, which is the Selenium's CDP and BiDi codified browser developer tools. So ChromeDevTools Protocol, that is CDP, and BiDirectional WebDriver Protocol, that is BiDi, provides support for low-level debuggability requirements of the web testing world. Both use Websocket for implementation to provide two-way communication. Now in this talk, Puja will kind of cover what are CDP and BiDi and how is the CDP support for sending CDP commands and receiving CDP events in Selenium. Also, along with that, she will demo on few things such as network interception, DOM mutation observer, web authentication, and getting JavaScript logs using user-friendly Selenium BiDi APIs. With this, I would like to hand it over to Puja for our detailed discussion on this.
Thank you so much for the introduction and this lovely opportunity. Just to ensure we are on time, I'm seeing the time as 4:28. That gives me, as planned, I think 35 minutes to talk. I just want to make sure everyone can see my screen.
Yes, Puja.
Okay, so that's great. Let's start. Thank you for going through the abstract and giving an introduction. Really appreciate it. Thank you everyone for joining today. So as said earlier, today I'll be talking about Selenium CDP and BiDi, the codified browser developer tools. So hey everyone, a lot of you may not know me. It might be the first time we're meeting. So glad to be with you all in the same presence. My name is Puja Jagani. I'm a part of the open source team at BrowserStack. I am a team lead there. I primarily contribute as a part of the open source team. I primarily contribute to the Selenium repo. I've been working with the Selenium open source group for about 2.5 years. I'm also a part of the technical leadership committee, which is where we discuss the new features, what's going to be there in the new version, any major concerns and all technical decisions. It sort of happens in the open on our Slack channel. If you have any questions, concerns, or after the chat and want to reach out, feel free to reach out to me on my email, LinkedIn, or even in the Selenium chat room. I pretty much hang out there all the time, and we can always sync up on whatever is required. So the agenda for today is, first we try to understand what are DevTools. Once we get a good idea of what are DevTools and how they're used, we sort of move on to the ChromeDevTools Protocol and why it exists in the first place, and get a little good overview of that. Then we move on to how Selenium provides the the CDP support. We call ChromeDevTools popularly known as CDP. So how Selenium provides the CDP support, and then we discuss what is the future of CDP, what is the next step, which sort of leads us to the WebDriver BiDis. We do a demo because it's not going to be fun if I'm only been talking for 35 minutes. And after that, we see what is the BiDi's current status. So developer tools. What are developer tools, right? So if you look at the definition, you go to Wikipedia, what you see, it says it's tools to test and debug code for web developers. But what does that mean? Like, you might confuse it like, hey, when I write code, I have these tools in my IDE, but it's a little different when you're doing web development, right? So when you're developing your website, in the IDE, you're able to step through the code. But what about when you want to sort of debug the user interface part of it? You want to see how the website looks, are the correct styles applied, those sort of things, right? So this is where developer tools come into the picture. They're actually pretty much integrated in all modern day browsers, in your Chrome, Edge, Safari, Firefox. They are there in all the browsers where you can see how your website looks and sort of see the HTML and the DOM structure at a very high level, and then drill down as required, right? Now let's go through this. I think this is something a lot of web developers must have already seen. But a typical flow is if you're developing a website, you start your local server where the website is hosted, you open a browser to see how the website looks. And at that point, you see your website being rendered. So as it's rendered, you're able to see its DOM structure and you want to dig deep. So what you do is you go to that page, right click on inspect. I think web developer tools is also popularly known as inspect element. I think we're very familiar with this. And then that is what opens this window on the right? Um, that is your DevTools panel. Technically, it's essentially what happens is you were able to see the elements section is showing your HTML structure and the DOM structure inside, and you can dig deep element wise to see what styles are applied, how does it look, how is it structured, and dig deep into that. Additionally, you can also see logs for it. You can see console logs, you can see JavaScript errors, anything, any exception or something that is ideally displayed on the console when you're interacting with the website, that also be displayed. Another part is you can also sort of profile um, your website. If you want to see how performant it is, there are also a performance insight section where you're able to see how quickly does it respond, how much if there's some sort of memory footprint it leaves. So these are very rich set of features to test your website. Apart from seeing how it looks, that these are additional layers that help you sort of give you that very low level debuggability power. So now we have this, but this is very manual in nature, right? You need to physically go do this, check, verify everything, double check, and do that step. But what happens if I want to automate this? We always talk about test automation, and that's pretty much what Selenium does for you. It's essentially a browser automation framework. Whatever you do is entirely up to you with it. But if you want to see how your website looks and works on different browsers, you use a framework like Selenium, or there are a lot of other frameworks in the market as well. So to automate it, you need a codified version of this. You should need to be should be able to access it via code, right? So that's sort of where it leads us with the actual protocol. So now let's come on to the overview of Chrome DevTools Protocol. So Chrome DevTools Protocol, also popularly known as CDP. But let's understand, why do we need a protocol in the first place, right? You're like, it's in the browser understands everything. Why do we need a protocol? Essentially, the need for a protocol comes in. It is sort of like a contract between two entities that communicate with each other. It could be any entities, right? They need to be aware as to what are they receiving, in what format is it expected to receive, a common semantic that is shared. So a receiver understands any content they get, and vice versa. If a receiver responds back to the sender is able to interpret the same. That forms the basis of any sort of a protocol that exists pretty much in the world. So now the Chrome DevTools protocol sort of exists to communicate between the DevTools and the browser and vice versa. So you have your web browser Chrome. Any event that happens when DOM is loaded, your network requests are being fired, or even performance related information to download a resource or to get more resources, it has all that information, but it needs to pipe it through, communicate it right to the DevTools interface so that you see it and it's being there. So that's this communication between the browser and the DevTools happens using the Chrome DevTools protocol. It's a common language that they both understand, right? That's why you need a protocol. And it sort of gives you consistency. Like for all Chromium based browsers like Edge or your Chrome, they understand CDP and they know how to work with it. And hence they have this whole developer tools window available, right? So it gives you sort of consistency. Additionally, since Chrome DevTools protocol is able to communicate with the browser, right? And at the same time, because it communicates with the browser, it can also communicate with the Chrome driver. Chrome driver is nothing but a binary that you download for testing purposes that knows how to talk to the browser and drive the browser. So the same protocol sort of used for Chrome driver, which makes it easier to use it for automation purposes as well. Okay. So now let's try to understand how Chrome DevTools protocol it's structured. The way it's structured is it's divided into domains, commands, and events. Domains Let's try to use it more of like a object-oriented analogy, where you have classes, right, which groups your related methods and properties together. Similarly, domain is that logical grouping. It's logical grouping of all the commands and the events together so that they are all in one place. It's just structured that way. Next comes commands. What are commands? Commands are essentially giving instructions to the browser to do something, right? You give it a command, you instruct it to perform a certain action, or you instruct it to retrieve certain data. That becomes your command. An event. What is an event? Event is a signal that something has happened in the system. Browsers are intrinsically event driven in nature, right? When a DOM is loaded, there are a lot of events that are fired, and browser picks these up and uses this information again to, in your developer DevTools window, and that's how it works. So the DOM is just one example. As we further on, we will see in the protocol there are a lot of events that are available that browser is driven by. So these are the three core things. We'll have a look at how they're structured in the later thing and how we can use it in code, more importantly, in the next slides. Let's talk about the pros. So Chrome DevTools Protocol internally uses WebSocket. So that makes life a little easier because now it's two-way communication, and you need two-way communication for things like events, because the browser will want to push something, to the client, and vice versa. You would want to ask browser to do something. So you want that two-way communication and that pipeline established, which makes it faster. Why is it faster? If you're doing a HTTP request response method, you always need to have a handshake. You need to set up new connections and do that. With WebSocket, you do your handshake once, you establish the connection, and you could just use that. That's why it's just faster. And as we discussed previously, Chrome DevTools Protocol is very, very powerful. It gives you a lot of low-level debugging capabilities. Like, essentially, you test your website in terms of how your UI looks, but for your networks, to simulate how it will look on a device, to get your console logs, to see all your DOM mutations, that sort of power, it comes thanks to CDP. Now let's come to the cons. It sort of matches with the need for the protocol in the sense, because protocol is meant to be consistent, but however, this protocol is designed to be consistent only for the Chromium browsers. The other browsers in the market like Safari or Mozilla, it does not work with them. Mozilla has done a good job to implement a subset of CDP, but that is just for puppeteer support. So it's a very half-baked support that you see. So anytime you're using Firefox, things break while using CDP, there is a good chance it's because of this half-baked support. CDP has one more caveat. It's specific to the version. So with every version, there might be a breaking change. So you write your code today, you're sending CDP commands, all is good. You're sending in, say, 4 parameters. And tomorrow, with a new Chrome version, it might require 5 parameters, and your code will break. So that's never good, because it just affects maintainability, to be honest. And Chrome releases versions every other month. You don't want the code to be breaking. And while it supports automation, but you need to understand that the way it was designed was not with automation kept in mind. It was designed to give this physical DevTools experience, right? So it doesn't keep that need for automation, the common use cases. It does not necessarily address that in a straightforward manner. Now that we've seen how domains, events, and commands, they sort of coexist, like how you have a domain under which you'll have for the domain, you'll have the commands and the events, and you might have some commands to enable certain events, and events are fired, and you may be able to capture them. They all sort of sit together in this tight ecosystem. Let's look at how the code for the same looks in Selenium. Okay, so this is a simple snippet of how we use CDP using Java. We have the same support is available in all languages as well that Selenium supports. So first line that you see is, a Chrome driver is being initialized. A simple session is created with the Chrome driver. We try to get the DevTools instance. We just say, hey, give me DevTools instance. You get a DevTools instance. You say create a session. That is your initial WebSocket handshake connection that is established. That okay, WebSocket connection is established. When you do create sessions, there are certain domains or certain things certain events and methods and commands that would need to be called for that handshake. That's what happens in the background as a part of it. And later we move on to actually sending the command. When we do devtools.send, we're sending the command. Now, if you see the command, it says emulation.set geolocation override, which means emulation, the first part is the domain. Under emulation comes the command that you're able to set the geolocation override. And these are the parameters it needs. Parameters are nothing but latitude, longitude, and accuracy of the geolocation as to what do you want the location to be set. And after that, you can use your Selenium commands to go to a particular URL and see if that location has changed. It's a very simple way, a simple example to do this. Now let's see. Like I said, it supports all domains, right? So now what happens is like we just saw. So this is what Selenium does, and I will explain it. But like you see, you're able to see clear geolocation override. Similarly, we were able to set geolocation override. So this is the emulation domain with all the necessary methods or commands and the events it listens to, and types. Types are just so that you know what you're going to receive if you're requesting for information. Entire protocol is structured into domains on the left, if you see, right? Now, same thing. So what Selenium does is it supports all the domains, events, and command listed in the protocol page that we just saw. It takes the raw protocol, maps it to classes, methods, and events and types, and provides that to the user. Since it's version specific, with each new Chrome version, we are required to sort of download the protocol, which is available in the open source repo, do the mapping, generate all the classes, generate respective binaries, attach it to the Selenium libraries, and sort of ship it out. It's a lot of maintenance work per version, but we try to keep up in terms of any new version comes in, we try to make sure we try to release within a week so that we can support the latest CDP protocol. Now, this example is again very similar to what we saw earlier. So the first 3 lines are exactly you're initializing a driver, getting a DevTools instance, creating a session done. You're enabling the log. You're like, hey, I want log related domain. Can you enable it? This is an instruction where it will not return information. You're just instructing it to enable this. Now add a listener. Add listener is the part where you sort of listen for the events, right? You tell that if a log entry is added, just inform me, right? Let me know when a log entries are when this event happens, and you take some action. It's a very simple example. So this sort of covers how Selenium is able to support its domains, events, and commands for almost any protocol version that comes in. But like I said, it's version specific. So if you're sending something today, the code works. Tomorrow it might require more parameters, or the event name has changed, things have been deprecated, it may or may not work. So version wise, if you're using, please be careful. What I showed is how Selenium supports raw CDP. Like you need to understand, you need to know the commands that exist, the domains that exist, what do they do, why they do. It's a lot of process and overhead for anyone testing this to actually understand and do this in the raw form. We just provide the support because we'll see in the future, we don't have that BiDi stuff set up wholly yet. And again, we'll go through that later. This is not a recommended way of doing things, to be honest, because it's a lot of overhead for anyone to maintain this code. But if you really need it, this is something that you can get started with because this is supported in all Selenium language bindings. Now, BiDi. But why BiDi? Why do we need this WebDriver bidirectional protocol? We already have CDP, but we went through the disadvantages of CDP, right? It being version specific and not consistent. But before we understand that, let's quickly just go over the normal flow that Selenium has. Selenium has, if you have a Selenium client, it knows how to talk using a WebDriver protocol. WebDriver protocol is nothing but a standardized protocol that all browsers understand, right? It is difficult to implement things inside the browser. So it was sort of extracted out into something called as a driver, which we call it the web driver, which knows how to drive the browser, how to talk to the browser. So the common communication that exists between Selenium and WebDriver is using the standard protocol, which is same for all the browsers. So any Selenium client or any other framework, they can use this common protocol and just assume any browser on the other end will understand it, which is essentially the WebDriver component will understand it. Internally, how the WebDriver talks to the browser, might be implementation specific. Chrome might have its own way, Mozilla might have its own way, right? And this is simple to test your website's interaction, to fill forms, to do those sort of basic UI testing. This is what this WebDriver protocol was designed keeping in mind. With extended needs and need for low-level debuggability came in the BiDi protocol. Now, BiDi protocol, it provides very CDP-like functionalities, but it provides a two-way communication. It also uses WebSockets, right? WebDriver was sort of doing a request response. It uses HTTP. Whereas WebDriver BiDi protocol, it's more standardized. It aims to be standardized in the sense it aims to provide that when you're sending commands for any browsers, it will understand, not just Chromium-based browsers. So that's one advantage over CDP. And also the way browsers are developing is instead of directly building this WebDriver protocol only in the WebDriver, they're also trying to put it in the browser itself, right? So at some point, it will be possible for Selenium to directly talk to the browser without the needing to download this WebDriver binary separately. Now BiDi, again, let's go over why do we have this BiDi. As we mentioned, it's a standardized approach. It's developed by the WC3 committee who developed the WebDriver protocol, which is standardized approach for all browser vendors to go ahead and implement these APIs to allow testing. This is the same approach it follows, but to use WebSockets. It's not browser specific. Once the BiDi protocol is in place, it's not specific version-wise for browser. Browsers are required to adapt it. Yes, they might do it incrementally till they complete it. They're required to adapt to the entire protocol as it is, and the protocol is something that can evolve or add items, but it will never lead to breaking changes. The way the protocol is developed, it's with keeping automation scenarios in mind. Yes, it provides individual commands and domains and things like that, but it never will try to increase the burden on someone who's testing. It's try to keeping the person who understands testing in mind and not person who understands the browser. There's a difference, right? The way CDP is, because it was devised to communicate with the browser, the commands are very specific to how browser functions, right? Imagine me as a tester. I don't know how browser functions. I don't know how these commands map to what I want to do. But instead here, the aim is to design it in a way that the end user, the tester understands it. Those needs are kept in mind. Like we saw earlier, it is complementary to the WebDriver protocol, right? Like the WebDriver protocol sits. Same way, every time a WebDriver protocol session is created, you can also create a BiDi session. It gives you that information to connect to the socket. It sort of sits in parallel with it. Along with that, as we discussed, a lot of browsers are trying that, users don't need to specially download the driver. They're trying to implement this BiDi protocol within the browser, so you can directly communicate with the browsers to test it as well. And like I said, it gives you all the low-level debugging capability that you have as CDP. It doesn't mean CDP to BiDi move is just a lift and pick of the same protocol. A lot of thought process goes into what is required, what is needed, what is not heavy for the browsers. Keep in mind, CDP is very heavy and very complex for browsers to implement. So the way this is designed is keeping both the browser vendors and the end users in mind. And the one beautiful thing about this I like is there's a working group that meets every month to discuss this protocol and design this protocol and iterate over this protocol. And that group consists of members from Puppeteer, Selenium, all browser vendors coming together to pitch ideas to discuss what happens. And they publish this meetings. There's also, minutes of the meeting publicly and their agenda as well. So it's sort of a very good collaborative effort, keeping the entire automation in mind. So now I think I've spoken enough. Let's quickly go over the demos of the different BiDi APIs that we have. But before the demos, let me say that since BiDi currently is honestly a work in progress. The protocol is being developed. As it's being developed, the browsers are slowly starting to adapt it since the last 1 or 2 versions, right? So the BiDi APIs that Selenium has tried to provide, it uses CDP in the background. So you will see a lot of CDP flavor or some CDP commands. And we will discuss in the last slide as to how all this will ideally clean up. But let's quickly start with the demo. This demo is to see how you can see console logs, right? Anytime something goes wrong, you want to see what the console logs look like. And this is exactly what this test will do. It's a simple test. We're initializing things that you need. We're setting up the test as required, right? Creating a session, doing a cleanup. So, right, so we're creating a WebDriver session, DevTools instance, and, cleaning up the browser with, like, quitting the browser when it's done, because it's highly recommended. And now let's move on to the actual part of the test code.
Puja, do you mind increasing the font, please? I mean,
I'm sorry, this is pre-recorded. I'm apologies, not able to see. Is it too small?
oh, okay, cool. Yeah, I mean, it looks a bit small to me, so I thought if it could be possible to. That's okay.
Yeah, I'm really sorry. This is pre-recorded, so not able to, but I can share the videos as needed, and I'll talk through it if that makes it easy. Sincere apologies for that.
No problem, no problem. Please go ahead.
Yeah, so we are enabling the log, we're enabling runtime, there's something like that. So like I said, there's some CDP flavor involved. We're adding a listener to listen to a log event. And when we do that, we want to add it to a list. We're adding another listener to this. So now this is the disadvantage of CDP that I was mentioning, to be very honest, in the sense where we have to specially enable two domains to listen to logs. And this happened later in the system. So Selenium developed this one API to listen to logs. Later on, it was deprecated and it was said that, okay, you need to either use a runtime or log domains. Either of it can generate this console log. So we don't know which one. So we have to add listeners for both. This sort of becomes inconvenient, right? I know this is a BiDi. In the future, when you have actual nice BiDi API, this will be a lot cleaner, just one listener, very straightforward. And that is the goal we are working towards. This particular case still has that flavor of mix of CDP. But let's go on. We are adding two listeners. And once we do that, this is a simple test URL that was there we use for Selenium test internally. Yeah, this is just sort of mapping that how actual DevTools and how codified DevTools look. You see, if you click on it, you see hello world, which is a console log. And as you click, you just see it more number of times, right? Now we just run the test to do that. So we go to the website, click on the element that you need. This is typical Selenium stuff that you do. We just sleep for a few seconds so everyone can see in the demo. And we pretty much go over the results and just assert. Yep, and a test passes. So now what happens is, so that was your console logs. Similarly, if you want to see JavaScript exceptions, right? So next. Similarly, for JavaScript exceptions, they are also displayed, right? If we write a similar test where you add a JavaScript exception listener, right? Instead of console logs, we want to just see JavaScript exceptions, so which is very crucial when you're interacting with the website. Again, we have a test website, the same page that we saw earlier. We just quickly go to the inspect, see the log and verify. And when you see, we're able to see one exception that says not working. It was just something that was created for a test, along with the stack trace, of course. And then we have a very similar flow. When you go to the website, click and just assert that we're exactly seeing that. We're running the test, opening the web page, just waiting a few seconds before we click. Again, the sleep was just for demo purposes, so that comes in, and here the test passes, right? So that is how we can capture the two types of logs. Now register basic auth. So basic authentication is a very common way to safeguard your resources on the internet. So if you're requesting something from a server, the request will go to the browser will pass it to the server will be like, hey, I want authentication, and it will sort of, give you a dialog box saying enter the username and password. Once you enter the basic username and password, you'll be able to easily access the resource. It's a very straightforward thing that sort of happens. There's a simple example that is being used in the sense, when you go to this http://bin.org, like this URL, it gives you a small prompt showing username and password. When you enter the username and password, which is nothing but foo and bar in this case, for this example, you'll be authenticated correctly. But let's quickly see what happens in the background, in the sense, the response headers and the request headers, especially the request header part, where we are actually, it shows basic and some encrypted password. This indicates that a basic auth information was sent. Let's quickly again look at the demo for this. Again, the setup and all is very similar to what we've seen so far, right? We initialize the driver, basic setup, DevTools instance. Do the cleanup. So in this, there are two options. If you see this API, it lets you register for a certain URL, right? You might have a website that might reach different authentication credentials for different resources. So you can mention that which credential is for which one. If you have only authentication for one thing, you can just remove this URI predicate, essentially remove the need to filter out a particular URI this needs to be for, and just go ahead with it. So you're telling which URL to work with and what are the credentials, like I said, foo and bar. So yeah, now you just simply go to the URL, just sleep for a bit so that we're able to enter things, see things in demo. Now let's quickly run the test. It's authenticated, all is good, and the test passes. Now let's go to Network Interceptor. This is the most fun feature according to me. So what Network Interceptor does is, before we go on to the slightly longer demo, but what the Network Interceptor does is, it first observes what's happening over the network. What are the requests being sent and the responses being received? Any web page is not just pure HTML, CSS. It has a lot of resources. It needs from the internet that needs to be downloaded, API calls made, database calls that you want to make, right? So all of this Network Interceptor is first able to observe. And if you ask it to respond or mock some responses, change some requests, the Network Interceptor will do it for you. Now, this is useful when you're talking with databases, when you're talking with when you're mocking some API calls that you need to do, right? So you can mock those sort of API calls, see when the request goes out and send mock responses. So we have a similar example set up, but it's a little more, we're not mocking a database request, we're just changing how the website looks. But again, it's a standard setup, and you initialize an interceptor with the driver you want it to work for, and then you tell what it should be doing. This is essentially a filter that you say that, let me just quickly pause here, in the sense, what I'm doing is, if my request contains this URL and it's a GET request, then send this response. You can do the same thing for a response. You can do it safely just to, if you want to only monitor all the requests that are going in, and let the request continue as it is, depending on the use case. These are simple Lambda functions in Java. Again, it's available in all Selenium languages. So each language will have its own thing. So let's go to, we've done this test on ehow.com. It's a lovely site with a lot of information, and you can see all these images that are there. We're again trying to just see how actually, it maps, the DevTools map to the codified part of it. Yeah, if you see, it requires so much information from the network because this page has a lot of images. It uses this particular server of its own to retrieve these images, right? And that is the exact request we intercept. We intercept the request made to get for the images and replace it with the image of our own choice. I mean, this example is for fun. A lot of network intercepted tests, do this. They either go to Facebook, intercept requests, and sort of, replace it with a cat image for fun. I have done something similar with eHow. Like, see, we're intercepting the same thing in request. We just see what request went through, and we are sending with a response. Yeah, it's just mapping the exact same thing, right? That's how the network tab is also useful, and you can codify it. And I'm replacing it with a smiley image from my machine. Now we quickly run it. Browser started. Now if you see, instead of the original website, we see all it's loaded with smileys, right? So that's just how it is, right? Because we did it for fun, but it's technically more useful for cases where you have calls to databases, things that safeguarded by passwords. You don't want to do it in your tests for that. Now, the last example that we have is the DOM mutation observer. All of us know DOM is a document object model. It is sort of object-oriented representation of the HTML document. And we often, programming languages often change these DOM elements to display things, to show things. And every time this happens, as an end user, you want to know when you're testing your website. For a particular web element, if it's changed, a property has changed, if something related to its DOM structure is changed, you might want to notify. That's exactly what this DOM mutation observer does. Let's quickly have a look. Again, similar setup, probably just yeah. And here we are saying that on a DOM mutation sort of event, just latch countdown. Latch is nothing but a waiting mechanism in Java that you wait for a while. And if that, when it's triggered, you count down and then it sort of waits till a particular thing happens in your code. Again, a test page that we have. If you look at the DOM structure, it has different ones. If you see the input, the style currently says displayed none. This is the original DOM property. When you click on this button, now the style has just changed to nothing. It's just into a default value that it's visible. We made it from invisible to visible. That's all we've done. We've not done anything different. It's a DOM change in that particular web element. Now we're just going to quickly observe that and see how it happens. Yep. So that was it. This was DOM mutation. Our test passes. What we did is we quickly just waited for a mutation to happen and just asserted on it. We would also take the information from the mutation and just verify the property if it has changed. What is it? And just check on it. And that should be okay too. So that's pretty much it for today's talk. The last slide is BiDi's work in progress. So like I said, CDP is something that's been there. BiDi is something that was sort of born out of CDP to make things standards amongst browsers. So BiDi as a protocol development, it's under works. If you see, this is the WebDriver protocol draft, and it's editor's draft. So it's working in progress. If you see on the left, there are some section called modules, very similar to domains, like we discussed, and then it has these different types, which are nothing just but objects and different commands that it has, and events, right? So it's working in progress right now. Each browser is working at their own speed to deliver this, right? So if you want to go Chromium, if you want to see where the Chrome driver things are at, you can easily, I think this was it, I'm not sure. So each driver will tell you as to what do they have available, right? Like if there was a BiDi mapper that they were working on, when do they added in 106, they added the basic support for, BiDi. So they're incrementally working on it. At the same time, you can also see what Chromium is doing. This is one thing I really, really like, is they're developing the protocol, they're putting it in Chromium, but using different user milestones, right? So you have these different scenarios they're defined, and based on the scenarios, they implement those necessary APIs. They're not going that, hey, this is the protocol, let's do this. They're actually keeping users' scenarios in mind and implementing it. And they're also the plan in the future is to collaborate with Selenium to give an idea what end users need. So, it can be sort of looped back into BiDi. Mozilla is doing very good work on it as well. They have this lovely document where they talk about each milestone and what is implemented, what is pending, what are the bugs related to it as well. So all browsers are working in effort over this common protocol. It's just lovely to see that. This is Edge and Chromium's roadmap as well. It's a public document, but they have everything defined, what they want to implement, how big the items are, how they plan to implement it. So, I mean, they also have a very strong plan to do this. One thing which they want to do, which is similar to Mozilla, is integrate BiDi into the browser itself, not in the WebDriver, so that users, if they directly want to just communicate with the browser using BiDi for their automation needs, they can do that without having to download this Chrome driver or Gecko driver binary, right? So that's how it is. Apologies. And now one good place to see what's happening is this. I don't think a lot of people know about this. These are web platform test dashboard. This is where any feature that comes for the browser is tested, tests are written for it. So you can easily compare between different browsers if a particular feature exists or not. Like we went to the test BiDi repo, different domains, what part of it is completed in which browser. Red means there's no support for it, partial support for it. It's essentially a dashboard that'll give an insight as to how the progress looks at a given point of time for the latest browser versions as they're developed. So that's it. Selenium has currently started implementation on the BiDi work for Gecko driver and Java binding. Ruby also has some initial support to make these BiDi connections. Selenium is currently me and Tamzil and the other members of the technical committee are sort of helping us give feedback. We're developing a tech spec that creates a unified API, an API that doesn't let the end user know if it's DevTools or BiDi. They just get the instance and just work with it. A very smooth unified API amongst all languages, something that is very user-friendly, focused on only user scenarios, no need of raw commands and events need to be passed. So that is the spec that we're working towards. We're almost there in terms of, identifying or agreeing on it, and slowly we'll start working on it so that at least we're able to keep up with the browsers. So that's it, folks. Sorry, just references and courtesies, and thank you. I am open to any questions that anyone has. I will just stop sharing so it's a little easier.
Thank you, Puja. Yeah, there are a couple of questions. If
Okay.
you can take them in the Q&A. Shall I spell it out for you? Or?
Let me just quickly see the Q&A.
Okay.
You guys see, yeah.
Feedback.
Can I ask the question?
Okay.
So, it was a really nice session on CDP.
Okay.
So my question is, lots of browser are Chromium based. So CDP command, whatever you showed, it is only for Chrome based browser. Can be used for Edge?
Yes. So what I showed this for Chromium based browser. So it's for Edge as well. So what Edge is so Chromium is like the parent repo from which Chrome and Edge sort of extract their information. So anything that works in Chromium should work in Chrome and Edge. So what we showed should work in Chrome and Edge and partially in Mozilla, because Mozilla, like I said, they did a half-baked support just for puppeteer purposes. But ideally for something that works on all browsers, for a website one wants to do cross-browser testing, future is BiDi. That's the standardized way. That will be the standardized way to do things. Currently, Chrome is working on a BiDi support, and what it does internally is, if you send a BiDi command, it maps the BiDi to internal CDP command that browser understands, right? But slowly they're working on removing that as well. It's going to be through and through BiDi.
Thank you. I am having two more questions. Let me ask. So,
Yeah, sure.
next question, it is for network intercept. Is a feature of Selenium 4. We
Mm-hmm.
can intercept the network. So
Yes.
this is a feature for blog URL where we can block some images. When we are opening some web page, images will not display. So
Hmm.
that feature I have tried. Just I want to know it is working sometimes. Sometimes it is.
So is it a sorry, is it a concern like so I'm just sorry, I'm just trying to understand the question. So are you saying the network interceptor feature that you're seeing is like your work using is not working consistently? Are you facing a
Yes, yes,
problem?
yes. Have you come across that? That is my question.
So it's again it depends on what exactly the code looks like and which language binding. I've not personally come across it. I work a lot on Selenium's Java bindings. But if you've seen a bug that is easy for us to reproduce, please feel free to file a bug on Selenium's repo and I will take a personal look at it. Reach out to me on Slack channel if you need. We'll take it up in priority if you're able to reproduce it. So as long as you have a reproducible test script that's easy for me to also reproduce on my end, we can go ahead and solve it. I know we have some existing issues with .NET Network Interceptor, and we have been trying to triage it as well.
Okay, thank you. Last question related to the emulate location, as you showed the example.
Yes.
So like where this feature can work. So there are a couple of websites. It is working. Some websites is not working. So what is any prerequisite where it
So
can
it
work?
depends. Sometimes there are permissions that need to be enabled in the browser. So you might have to double check, right? So your browser has these geolocation permissions that might need enabling. So you might just need to double check if those are enabled when you're running the test. That is as far as it goes when it comes to emulating a geolocation.
I have a
Okay,
question.
thank you.
Uh, I have a question. So Selenium always begins with element locators, right? When you're trying
So
to automate web apps.
okay.
So can we, has there any thought been given to that the user records actions in the browser, the sequence of things he or she is trying to automate, and Selenium automatically generate like a code generator for Selenium.
So the thing with Selenium itself is not working on having a code generator for Selenium itself. But if you want like a code generator, I think we have a Nightwatch is a framework. Again, it's a part of the open source team and BrowserStack, which sits on top of Selenium for JavaScript that has these code generator sort of capabilities, right? So Selenium as a framework, the goal is to provide this standardized approach to talk to the browsers to allow cross-browser automation. We've not dug into a special generator sort of a model yet.
But often that is the source of the flakiness often. Selenium.
Yeah, it's not exactly the source of flakiness, I would say. So flakiness is due to how browsers are intrinsically, to be honest. Like there are frameworks out there which say, okay, we don't do flakiness, but they do internal retries or internal waits. At the core, it becomes the same thing because browsers are event driven. They're not exactly predictable in terms of the load times. Sometimes that's why things don't go as expected as you would want in a particular test. But I think code generation and test flakiness, those are so separate problems, right? Code generation would be essentially a typical use case that you would just want a code snippet or like a skeleton code for. And flakiness would be how the website loads. There are a lot of features or a lot of factors, sorry, that you cannot necessarily control from browsers and the way browsers are intrinsically designed, right? So Selenium gives things like explicit waits or implicit waits that you need to wait to do it. There are other frameworks which will
Would
say no
BiDi
flakiness.
would BiDi improve performance in terms of flakiness?
It may be or maybe not. It actually depends on what APIs are there, right? So if there are certain browser events that need to be waited for, that browser actually waits for and then goes on to display like all the DOM mutation stuff, DOM related events. You could essentially in BiDi, you could use such APIs, wait for a particular element to show up and then assert. So if that is some flow, then it may definitely help as far as I understand. But we will have to see.
BiDi is browser specific.
No, BiDi is not browser specific. That is the entire goal of BiDi. BiDi is developed by WC3 Group, which is a standard. Like WebDriver is a standard to allow cross-browser automation. BiDi is a standard that all browsers are expected to adapt, right? So all
But
major
if-
browsers.
if BiDi directly talks to the browser, it has to be browser. If there is no intermediate layer.
Yeah, so the thing is, when you talk to BiDi, it's two factors, right? So BiDi even directly talks to the browser. Browsers are implementing it using the WebDriver protocol. So it's the same channel of communication. When you talk to BiDi, like if Selenium talks to BiDi, it understands what we are saying in a standardized manner, right? It just follows. Everyone is implementing one protocol in the same way. Internal code to do that might be different, which is not a concern for anyone interacting with BiDi on the outside, right? So internally how it talks, it does not matter. But when you talk to BiDi, like BiDi sitting in the browser knows how to understand that and respond to it. They might internally have different mappers and transformers and different converters inside code wise, but that does not really concern any testing persona, right? All we need to know is how to talk to BiDi, and we are sort of frameworks will abstract that to make it very, very easy and not like very low level also.
Pooja, I have a question. Can we run these tests in headless mode?
Yeah, I think most of these tests should run in headless mode, but the one caveat is I think geolocation override does not work in headless mode. It is a Chrome caveat. We filed a bug last week on ChromeDriver. They're like, we don't support this. So you might just need to verify what doesn't work in headless mode. That those kind of caveats do keep coming on and off. So ideally you should be able to, but what we discovered last week or 15 days ago was geolocation is not what headless mode supports. So it's their thing.
Maybe Puja, we can take the webinar question. So I'll help you out with the question.
Yeah.
So Deep is asking how to add these listeners and perform all this listening thing in Selenium Python, because he's seeing not much document on that.
Okay. So Deep, you have a fair point in the sense we have documented things in Selenium. Like if you go to Selenium website, we do have documentations for all language bindings. But because of the way async Python thing works, we I think don't have support for network interception as far as I remember, right? But if there's a missing feature, you see a problem, please reach out to us. We'll be more than happy to solve it. But most of these features are available in Python. And also regarding async in Selenium 5, we sort of plan to solve the problem so we can provide these features. We're iteratively working on a lot of things in parallel. Again, we are an open source community. We only have a handful of resources coming in to work on all the domain to take care of a framework like Selenium, which has 5 language bindings. It's a lot of heavy lifting that a few of the dedicated committee members do. Anyway, you can help by giving inputs, filing issues, pointing out, again, if you see there's something in documentation you can help with, again, resonating with Manoj's talk. All contributions are welcome. All conversations are welcome. Any idea discussions, feature requests are welcome. We'll be more than happy to hear it out.
Okay, next is from Kishore Padmanabhan. So he's saying, I was about to ask this question regarding accessing the network tab in developer tool. Thanks for showing that in demo. Do you know whether this is possible through C# as well?
Yes, so .NET has a network interceptor support. We have an example for it on the documentation website as well. But like I said, there are known bugs that have been filed currently by some users that we are trying to reproduce. They're intermittent in nature. But yes, this feature is very much there.
Yeah, the last one is from Wasim. So he's saying he has done similar kind of PFC using Playwright, and that was kind of fast compared to Selenium. And that's the reason this was mentioned as Playwright using Websocket protocol compared to Selenium, where it is using JSON-ware protocol. So if BiDi gets implemented, then will Selenium will be faster as similar to Playwright?
That's a fair observation to make. Just to correct, so Selenium used to use the JSON-wire protocol in Selenium 3. Selenium 4 onwards, we use the WebDriver protocol, which is a standardized protocol that all browsers understand. All browser vendors have implemented it since a particular browser version since a very long time now. So we use WC3 for our normal interactions. But yes, the speed and the advantage that we discussed in terms of creating a WebSocket connection and reducing that handshake, BiDi should be able to give you that performance advantage. There are also plans in the future with the WebDriver BiDi working group that meet monthly with the browser vendors to see how the original WebDriver right? And the WebDriver BiDi spec, how can they be merged or how they can properly sit along to give these performance advantages. But these are very, very long-term goals because different groups are working at a different pace to just get the BiDi stuff out right now. But yes, we do have a plan for that as well.
Thank you. Thank you very much, Pooja. It was really great having your session. And I think we answered most of the questions. So that's really great. Thank you very much for your time.